says a sound source of frequency. यहाँ पे sound source की frequency कितनी दे रखी है? Frequency दे रखी है 50 hertz. So we know the frequency to be equal to 50 hertz is producing waves in air. What type of waves? Since it is a sound wave, this will be a longitudinal wave. And the amplitude of vibration is 5 mm. Now see, here once again we are having the amplitude mentioned in not in SI unit, it's in mm. So I need to convert it into SI unit. So amplitude will become 5 into 10 to the power of minus 3 meters. So remember one thing, whenever you are going for numerical problem solving, always try to use SI system of unit. And the speed of the wave is 330 meter per second. Okay, and they want us to find a distance displacement equation of the wave. Now you know that for any wave, the distance displacement equation is given by y is equals to a sine omega t minus kx, and this is the equation for a wave which is progressing along the positive x-axis, So this is the equation for a wave which is progressing along the positive x-axis of a progressive wave, harmonic wave, which is traveling along the positive x-axis, where a stands for amplitude of the wave, omega over here stands for the angular frequency, and if you all can recall, omega is equals to 2 pi f. Wherever required, I am going to use omega. Instead of omega, I will use 2 pi f if frequency is given. And k over here is, if you can recall, it was angular wave number, and k is equals to 2 pi by lambda. Or one can also recall omega is equals to v by k. Can you recall this part also? So from these things I can relate k, omega. Let's see what is given. Since frequency is given as 50 hertz, so what I need to do, since in the equation I will be requiring omega and not f, so what I'm going to do, omega is equals to 2 pi f, f being equal to 50, therefore omega comes out to be 2 pi, substituting the value of frequency as 50, therefore omega comes out to be 100 pi radians per second. So now I've got the value of omega over here. A is already been known to us, velocity being given as 330 meter per second, and you know k is equals to, a correction over here, it's omega is not equals to v by k, v is equals to omega by k, therefore k is equals to omega by v. So let's substitute omega as 100 pi and v as, velocity has been given as 330. So this becomes, k comes out to be 10 pi by 33 per meter. So this is the value of k we have got omega, we have got a. Let's substitute into the equation. Y is equals to a. How much is a? A is 5 into 10 to the power of minus 3 sine, what is omega? Omega is 100 pi radians per second into t minus k. K की value निकल के आ गई. We have got it as 10 pi upon 33 into x. Let's take y into 10 to the power of minus 3 sine, let's take 10 pi outside of the equation. So once 10 pi goes outside of the equation, it becomes 10t minus x upon 33. So this becomes the distance displacement equation. This is the distance displacement equation in SI system of unit. Distance displacement equation in SI system of unit. That means the amplitude is in meter and all other factors are in SI units as per the requirements. Yes.